Hello everyone, I'm Aditya Shekhar Nittala and I'll be presenting our most recent work, Next Steps in Epidermal Computing, which identifies opportunities and challenges for soft on-skin devices. Human skin is a fascinating interface. It's always available and it produces and enables us to feel rich tactile sensations. We also have inherent proprioceptive capabilities which enables us to have a very sound knowledge about 3D space around us. And finally, human skin also acts as a biological interface which allows us to measure vital biosignals that signify the state of our health. These highly desirable properties are ideal for building the next generation interactive devices and immersive experiences, leveraging the physical and perceptual capabilities of our body. And recent research in HCI has been actively exploring novel ways to augment human skin with interactive functionality. These soft, highly skin conformable devices seamlessly and intimately couple with our body, giving rise to a new emerging field of computing. And this new emerging field of computing can be termed epidermal computing. And the vision for epidermal computing is to intimately couple sensing, computation, and interaction to the outermost layer of the human body, which is the human skin or the epidermis. And this epidermal computing is enabled through an ecosystem of epidermal devices. And epidermal devices are characterized by the following properties. Firstly, they are very soft. They are non-invasive, because of which we do not feel their presence on our body. They are highly stretchable and flexible, which allows them to adapt to highly complex body geometries. And finally, they are also biocompatible. In this work, we present the first multidisciplinary analysis of epidermal devices. By systematically analyzing research in multiple disciplines, journals, and across publishing venues, we compare and contrast research in epidermal computing in HCI and physical sciences research communities. And through this systematic comparison, we identify opportunities and challenges for future research in epidermal computing. Firstly, as part of our analysis, we identified 4 core research themes for advancing this area. They are materials, fabrication techniques, functionality of devices, evaluation and empirical studies, and finally target applications for epidermal devices. I will briefly talk about the opportunities and challenges for each of these themes. For our first theme, which is the materials, design of robust ultra-thin materials and stretchable conductors is an opportunity that needs to be very well explored. And similarly, safety and sustainability are other areas that also need to be focused for continuing research in this specific area. To illustrate, this figure gives us a good picture of the current state of the functional materials that are used for fabricating the state-of-the-art epidermal devices. As you can see, most of the devices which we are using currently fall on the right end of the spectrum, where the devices are stretchable and conductive to a limited extent. However, the goal for the future research should be to come up with new materials that are highly stretchable and at the same time should possess high electrical conductivity. This can open up a broad variety of applications and sensing opportunities for epidermal devices. For our second theme, which is fabrication, we identify that designing and coming up with new fabrication techniques that allow for mass fabrication or fabrication of high resolution devices and computational fabrication techniques is an open research opportunity that needs to be explored. And fabrication for large body areas is an exciting open challenge that needs to be addressed. And to go deeper into one of these challenges, current HCI research has mostly focused on devices that do not cover large areas of the body. However, fabricating devices that cover large body areas present challenges in fabrication, interconnects, and high stress levels. There is preliminary and more recent research in physical sciences community that's trying to explore and tackle this specific problem. Our third research theme is functionality of devices. And in analyzing functionality of devices, we have noticed that HCI community has made rapid strides in creating devices with novel input and output functionality. Even in devices that enable computing and communication, we are witnessing devices in HCI community that allow for computation on the go and also support wireless communication protocols, for example, NFC. An active area of research is energy harvesting, where physical sciences community has already explored various ways for harvesting energy. And this presents us with open challenge where this could be a promising area for investing our next research endeavors. The fourth theme is evaluation and empirical studies. And in this specific theme, we identified that studying interaction techniques, social acceptability, and in the wild studies while analyzing interaction performance for epidermal devices are still open research challenges that need to be tackled. And these are also very important challenges because empirical studies enable us to design interaction techniques for epidermal devices that allow for natural ways for interaction on the body. And finally, for application areas, we identify assistive technologies and accessibility as a very promising application area. Epidermal devices can leverage our proprioceptive capabilities to create accessible technologies that seamlessly integrate with the body. Similarly, sports and fitness, multisensory immersive experiences, and effective human-robot interaction are highly promising applications that need to be explored and can serve as target application areas for epidermal devices. In this talk, I have presented our work which systematically analyzes the research across multiple disciplines and presents opportunities and challenges for epidermal devices or soft on-skin devices. We identified 5 core research themes, which are materials, fabrication, functionality of devices, evaluation and empirical studies, and application areas, and highlighted the possible opportunities and challenges for advancing the research in epidermal computing. With this, I will conclude my talk. Thank you.